Hello world, this is Lisa Fredrickson, your friend and computer science professor. In this short screencast, I'm going to be talking about Coding Bootcamp 101, what you need to know before you spend $10,000 or much more on a coding bootcamp or a computer science degree. Coding bootcamps are all the rage right now. Sometimes they're called full stack programs, web app development programs, software engineering, and I have many students that are interested in them because they often pretend to give students a fast injection of very valuable knowledge and help them find a job, a super future, and a career. But sometimes they throw so much information at a student right away, they're confusing to evaluate. So the goals of this particular course are to study the pros and cons of coding boot camps versus formal computer science degrees, to build a foundational working knowledge and vocabulary of the core areas required to build a full web application, which is often called the full stack, understand the best learning path and sequence for coding boot camps. I've been in this field for decades, and I do not believe we are currently encouraging students to learn the full stack in the best sequence. So I will talk quite a bit about what I feel the best sequence for you is. If you continue with me, I will also give you meaningful hands-on activities in each of the core areas that comprise a web application or the full stack. We will also study alternative technologies in each of the main areas of the full stack. And finally, and most importantly, we want to make informed decisions about your future as it relates to software development. I want to help you get to wherever you're going as quickly and as meaningfully as we possibly can. There is no one answer for everybody. One size does not fit all. Who should take this course? This course is for anyone who may be enrolling in their first coding boot camp, online or immersive, enrolling in their first computer science degree program, changing careers with an interest in software or web app development, or perhaps you're just wanting to understand and evaluate the current environment better as it relates to boot camps, web app development, full stack development, software engineering. This course is not intended for an experienced software developer who's already well into the field and who has already built web apps, unless you potentially want some thought processes to explain what you do to your friends or to encourage a friend. This course may be for computer science degree graduates. It really depends on where you got your degree and what was taught, and if you know where all the pieces of the full stack fit, and if you know where your skills in the full stack fit. So before starting this course, students should have a current computer, Mac or Windows, and a reliable internet connection. You should also have a quiet place to work and learn. And you should also be ready to take some notes and record questions. When we use software, it's going to be freeware, and I will explain how to download it. Now, this little screencast is free, and I hope you're getting something out of it. But if you stick with me and take my 5 short courses that go over the 5 main areas of the full stack, I will also send you a spreadsheet that will help you evaluate whether a boot camp or a computer science degree is better for you. And some of the issues that spreadsheet helps you evaluate are things such as, do you need college credits? Do you need a degree? Or do you already have academic credentials? In which case, non-credit boot camp might be just what you need because it would provide you the information. Time frame is a huge issue. Boot camps tend to be much more compressed. Of course, sometimes you can go to a college or a community college and get a computer science certificate in 1 semester. The money between boot camps and computer science degrees can vary greatly. Oftentimes, boot camps are about $1,000 a week, and typical full stack boot camps are 14 weeks. So that's about $14,000, $15,000 for a boot camp. And oftentimes you have to commit to that up front. At my community college, a 1 credit class would be $89, so a 3 credit class would be less than $300. It's much more incremental. Immersive versus part-time. That just means, are we going to be in boot camp full-time, or must we handle this in a part-time way? I have seen some boot camps that are offered in a part-time fashion, but for the most part, boot camps are typically immersive. They want to get you in, inject all the knowledge as quickly as possible, and get you out and get you a job. Face-to-face versus online is another consideration. Face-to-face courses obviously have a wonderful benefit that you're right there in the classroom with the other students and with the teacher, whereas online has that big benefit of flexibility. However, you have to be more disciplined, and oftentimes you are doing much more reading, because after all, you have to read everything in an online situation that might be said in a face-to-face class. So you have to know yourself and know which you are better suited for. There's a third type now called hybrid that attempts to combine the best of a face-to-face class and the best of an online class. And so those are worth looking into as well. Synchronous versus asynchronous, those are really just fancy words that I wanted to throw in here to make sure that you knew what they meant. The best example of a synchronous class is the old-time correspondence class, where the instructor sent you an assignment and then you finished it and sent it back in. Email is synchronous. Asynchronous means we're all in the classroom together. Asynchronous learning is faster and oftentimes less frustrating for the student. So regardless of whether you're face-to-face or online, look for an asynchronous component to your class so that you can really rub shoulders with those students, whether you're actually physically in a classroom or you're in a Skype session or you're in a Zoom session, so you can have that asynchronous learning as well. Pair programming, that's a new phrase. That can be a wonderful thing. Friendship can be the secret sauce of learning. I have noticed that when people make friends in the classroom, they are just naturally more motivated to come to class, to learn. They have someone to lean on, and it can just be a fantastic experience for you. Those situations where you're forced into groups or you're forced into pairs or you're lockstep with a group of people through an entire degree, I think can sometimes be miserable experiences. Let's talk about the full stack. The full stack programmer is someone who understands and is capable of handling all of the technologies in a web application. And those technologies break down to two key areas. The front end. The front end is the web page that you're looking at when you're surfing online, and they consist of three main technologies. HTML to describe and structure content, CSS, cascading style sheets to style and layout content, and JavaScript, which provides user interactions with the content. So as you're clicking on the page is changing. The second major part of the full stack is the back end. That is a server-side language to read and write files, as well as database technologies to store and manage the data. If you are capable of handling all five of these areas, you are called a full stack programmer. The unicorn on this slide is to indicate that some people claim there are no full stack developers, because how can one person possibly be fluent in all five of these areas? So some people would call a full stack programmer a unicorn. I have to disagree. It is totally possible to become proficient and fluent in all five of these key areas. Now, you may not be an expert in every area, and when we get to the back end, there are many different server-side languages that we can use, and there are also different database management tools that we can use. So it's extremely unlikely that you would be fluent in all the options on the back end. But if you stick with me, I will help you see where each one of these key technologies fits. We'll go through hands-on, meaningful exercises so that you can experience it firsthand, and you will finish by understanding the pieces of the full stack and how they work. And that knowledge is extremely powerful. I want to review the stack and also the order in which I highly recommend you learn the full stack. Number 1, learn HTML. Learn it well. It describes and structures the content on a web page. Secondly, you'll want to style that HTML. That's CSS, cascading style sheets. It will style and lay out the content on a web page. Third, take JavaScript. Make that your first programming language. You have to learn it anyway. Very valuable. It's the world's most popular programming language because it's used on every web page to change content and styles based on user interactions, clicking and scrolling through the web page. These three components constitute the front end, and they are not going to change for a long time. So learning these three technologies will allow you to say, I am a front-end developer. On the back end, you have two major technologies. Number 4 in your sequence would be databases, how to model databases and how to store and select data for a web page. You'll be learning about MySQL, SQL Server, or Oracle as the database management system. Once you learn one, your skills will apply to the others pretty well. You'll also learn SQL, structured query language, which helps you select, insert, and update data in a relational database. And last, learn a server-side language. Now, this can be PHP, Python, Ruby, C#, even Java. Learn a server-side language which takes the data out of the database and creates HTML, CSS, and JavaScript, which constitute the technologies of a web page, which are then served to the user. Unfortunately, most colleges of all types start you right in on number 5. Thank you for listening. If you enjoyed this screencast, just watch for the next one in my playlist. Now go do something great.